we're going to be solving a system of equations with equal values method. So when they say solving a system of equations, that just means you're going to have two equations. So let's read the story and try to write two equations. Herman and Jaquita are saving money to pay for college. Herman currently has $15,000 and is working to save $1,000 per month. So as an equation, y equals, Herman already has $15,000. That's like his starting amount or the y-intercept. And, meaning plus, he's saving $1,000 per month. So that's his slope. He's gaining $1,000 every month. It's the growth in his account. So y equals 1,000x plus 15,000. Second character, Jaquita only has $12,000 but is saving $1,300 per month. So in similar format, she starts with her y-intercept of 12,000 and her slope, how much it's growing by, is 1,300 per month, the x. So in this case, the x is the number of months and y is the money in the account. Not just how much they start with, but the total at the end of how much time has gone by. And the question really asks us in how many months will they have the same amount of savings? That word "the same" really just means when are they going to be equal, and that's why it's called equal values method. Since both equations are in this y equals form, we kind of ignore that part and we make the two equations the same or equal to each other. So the way we solve this is we just rewrite it, the first equation equal to the second equation. So Herman's 1,000x plus 15,000 has to equal the same money as Jaquita, 1,300x plus 12,000. Notice the y's are not in the equation once you start the equal values method. And now we can solve for x. So I might start by minusing 1,000x on both sides to try to get the x's on the same side. 1,000 minus 1,000 cancels out. So we've got 15,000 equals 1,300 minus 1,000 is 300x. And then now the x is here. We have to get the x by itself. So we can undo the plus 12,000 by minusing 12,000 on both sides. 15,000 minus 12,000 is $3,000 equals 300x. And then the last step to get the x by itself, to undo the times 300, is to divide by 300. And if we do 3,000 divided by 300, we get 10. X equals 10. And so in terms of the story, if we think back, x was the number of months. So our answer is that it's going to take 10 months for them to have the same amount of money. And the next question I'm going to ask you is, how much money do they each have in 10 months? So that's the second step of solving a system of equations. Once you've solved for x, you need to go back, plug in your answer as the x's, and calculate the y output. So originally our Herman was earning $1,000 per month. So we're going to do replace the x with 10 months plus the 15,000 he had. So 10,000 times, or 1,000 times 10 is 10,000 plus 15,000 is $25,000 is how much Herman has at the end of the 10 months. And we can do Jaquita's as well. She had 1,300 per month. So we're changing that x to be 10 months from our answer below, plus $12,000. And that is also $25,000. And they should be the same from both equations because that was the whole point of the problem. When will Herman and Jaquita have the same amount of money? 10 months, $25,000. So that's called equal values method. I'll do one more example of equal values method. Solve the system of equation using equal values method. So we take both equations. First equation, negative x plus 2. Second equation, 3x plus 6. Since they're both in y equals form, we can set the two equations equal to each other. So negative x plus 2 equals 3x plus 6. And we're going to solve for x. So I'll first add x on both sides. Cancels out. 3x plus another x is 4x plus 6. Get the x by itself, undo the plus 6 by minusing 6. So 4x equals 2 minus 6 is negative 4. And then to get the x by itself, undo the times 4 by dividing by 4. Negative 4 divided by 4 is negative 1. So our x equals negative 1. Never stop here. This is a system of equations. It started with a y equals. So we need to go back. We need to plug in the negative 1 for these x's and calculate the output. So for our first equation, y equals negative, change the x to that negative 1 output that we got at the bottom. Negative 1 plus 2. So negative 1, it's really positive 1, plus 2 gives us 3. In the second equation, y equals 3x, plug in our answer of negative 1 for the x, plus 6. 3 times negative 1 is negative 3, plus 6 is 3. Both equations gave us that final answer of y equals 3. Second step of this problem says graph both lines. What do you notice? So let's graph the y equals negative x plus 2. The plus 2 at the end is called the y-intercept. So we put our first dot up at 2 on the y-axis. And the slope, the number in front of the x in this case, is a negative 1. So that means on our graph, we're going to have to go down 1 over 1 every time we make a dot. Down 1 over 1. And we can draw the line across. Then we look at our second equation, 3x plus 6. The plus 6 is the y-intercept, means we're going to start up at 6. And then the 3 is our slope, telling us that we're going to go up 3 over 1. Up 3 over 1. Or follow that pattern backwards. And we can draw the line through. And what I notice on my graph is that there's what's called a point of intersection. Both lines are intersecting here. And so the last sentence says the solution to the system of equations represents the point of intersection. Point of intersection. And on this graph specifically, the intersection point is at negative 1, 3. And we write it as a coordinate. Negative 1, 3. And that matches our answer from before, when the x was a negative 1 and the y was a 3.